Okay, so another part is the file organization. So this file organization is not like the file we have, like a Word file, PowerPoint file. It's not like that. This is like a physical storage, physical layer of a database. I remember at the beginning of the semester, we talk about, we have a conceptual model, implementation model, physical model, right? So this is about internally using hard disk, how can we save information? So for this part, for the disk storage part, I'm going to briefly talk about this because you are going to learn something more detailed in other courses. What I have here just serve the purpose of further when we talk about database storage, how can we work on things? Okay, so first of all, no matter how fancy you think about the conceptual model or the implementation model, eventually, physically, the data, they are stored as a file of records, and they are physically stored in disk. So we'll talk about, what the file of record looks like. So the question is how to organize those files, right? And how to access them sufficiently. So remember when we do a query, right? So when we do a query, we say select star from employee. We want to retrieve the employee information, and the employee information, they are files record saved in disk. And we want to quickly locate them and retrieve them. How do we do that? So this is basically the question we need to ask in the physical level, not only how to save them, but also how to get them back quickly. So now let's quickly summarize the physical storage, primary storage and the secondary storage. This is the one talk about the memory that can be accessed by CPU directly. And the secondary storage is about like a hard disk, for example. They cannot be accessed by CPU directly. Okay, so the data need to move from the disk to the memory, and in order to do calculations, any operations on that. Secondary storage is persistent. It has large capacity and also low cost. Okay, so let's see the database storage. We store the data on disk. They are organized as files of record. So they are files, right? So this is not like a file like we do like a Word file or PPT, right? So we already mentioned that. This is the one we carefully organized so they can be a nice organized file of records. And for each record, we care about the entity and relationship, but they all actually as a file record. So we don't actually have different like diamond shape or something to distinguish, but actually they all saved as a file record. We want to make sure we can locate the record efficiently. So there are two types of file organization. One is primary file organization, one is a secondary organization. So primary one is how can we physically organize our file record? For example, we can sort them, like we can sort them based on department number of employee, for example. We can use something like a B tree. And secondary organization is we do not change the primary one. Instead, we using another field to do something additional, like index, for example, and using that to help us to do the organization. And we are going to talk about both, okay, one by one. Okay, so let's see the disk device. That's the simply a structure like this. So we have many tracks, right? They are actually full a cylinder when we have many disks. And this can do rotation. So this one show you can do rotation here. And there's a read-write head can read the information from here. And the actuator can move near to the center or far away from the center. So in this way, any place in any of the track, when we have information there, we'll be able to use the read-write head to get information. Okay, so the main purpose here is we need to understand we do not, so CPU cannot access the data on the hard disk directly. So that's why we care about the disk blocking. So let's see what is the block. Block, we can divide the track into equal size block. They are usually done by operating system disk formatting. So that's why you don't actually see that often, but this can be done actually use a command. We have like different block size, depends on how you set it up during disk formatting. So that's actually, so they are not important, but this is the one I want you to know is blocks, they are units transferred between disk and the memory for processing. In other words, you don't have any units smaller than a block to transfer. Say I have one block that has 10 students information, and actually I only the first student. I mean, my query only requests the first student. However, I have to take the whole block to the memory to do processing. So you don't have any unit for transfer less than one block. And that's actually, you will see when we have, when you take a higher level class, we talk about, IO performance. We actually, using how many blocks transfer as the unit to do evaluation to compare. Okay, and so let's see, we have how to do the read and write. So we have the disk mounted in the drive, and we can rotate, right? I already show you can rotate the disk, and read-write head can, it's actually electrical component and related to mechanical arm. So if we use a fixed head disk, how many number of head is equal to how many tracks? So you have many read-write head in one disk, and they are fast, but it's more expensive, not common. So usually the movable head, so this is the one actually instead of many read-write head, you only have one and they can move. That's more popular. And so how to do the read-write operation? The disks actually rotate at a constant speed, and we can move the read-write head to a position right into the right track. And so basically, okay, so this is rotating, right? And so this one, when this move to near to the border or far away from the border, then you'll be able to read the different track information. And once we move to the right position, this read-write head is electrical component, can obtain the information, right? Okay. So let's see the time spent to do read and write. It including the time to find the position, which track to go. Also including the rotation time to go to the right position. So you see they are actually rotating, right? So this is rotating time. And then that's the transfer time. This is much smaller than this and this, just because this is actually the electrical component, but this is mechanical component. So in order to transfer faster, we want to a number of consecutive blocks on the same track or calendar, so it can improve the performance. And so compared to CPU time, loading the data on the disk, so this I/O cost is the major bottleneck. So that's also the things I just mentioned. You know, a lot of cases we'll consider performance, we're actually using the I/O and to see how many disk blocks we need to access in order to compare performance. Okay, so now let's go back to the database part. So we know we save information in record. So they are file of record. And so let's see the record, what the record looks like. A record is a collection of related data value of items. And for each record, we can have multiple fields. Like we can have field name and field type here. So like the employee record, say we have SSN, that's the name, and type is character. And what is a file of record is actually sequence of the record. So one record, and then we have another record there. And let me show you the fixed length record, and you'll get to see how to have record of files. So what is a fixed length record? This one means every record in the file has exactly the same size. So for example, we can have an employee record, and each of the record has exactly 71 bytes. So this is the one record, for example. What we have here is like this. And so say we start with name field, and we locate it from 31. I'm going to have social security number. And then from 40, I'm going to start with salary. And I keep doing that until the very last one. And I totally take 71 bytes in total. So the first byte is for name. And for example, 31 for this. And salary is 40 starting like that. That will be the salary. And this is the social security number here. So this one, every single field, like a name, we have a fixed size. SSN, we have fixed size. This is the easy one. And salary will have a fixed size, and also other field. So this is one employee record. Then right after that, we can have exactly the same thing, have name, SSN, salary, and that's for the second employee record. So you can see this is a fixed length record. We just have one record after another record after another record. Okay, so let's see the fixed length record. The good thing about this is everything I point to, right? No matter which position I point to, I be able to read from my schema because they will predefine how big is it. I be able to know what I'm reading here, right? And they are more easy to be, you know, put in the files because we know exactly how big is each one. But the disadvantage is also obvious. That is, okay, so I have some employee name really long and some employee names not that long, but I have to have one size here. And if I make this too big, I'm going to waste a lot of space. But if I make this small, then some employee, when they have long names, they cannot fit into this. So that's actually can waste of storage if you make it really long. But sometimes you have to because just some employee have long names. So that's the issue of fixed length record. However, this is easy to maintain. We don't even need to know. We don't need anything specific to say that's the end of the record, because mathematically you'll be able to calculate everything when you have fixed length one. Okay, so then variable length one means the size size of each of the record. It can be different. So this one has a couple of different variations of it, and you are not going to need this for this course. But it just simply, if you want to know it, just for example, each field, like a name field, we don't need to restrict how big is it. If you have like a longer name, you have bigger space. But if like my name, only 3 characters, that will be just really short, right? So that's variable length one. And for variable length one, usually we need some special characters to separate different field or different records. So it's already more complicated to control, but this one can be more efficient, actually more saving space purpose is a better design. But on the other hand, it makes things more complicated to see, why reach a certain point, like why say that the 100 bytes is what? I don't know, right? I cannot know directly. So that's for this. Okay, so let's see another thing called record blocking. So that we have records and they are allocated to disk blocks, and we already know that there are files records. Okay, and usually each block we can have many records. So not necessarily it doesn't mean you always have more than one record in one block, but in many cases one block can have many records. So if we give block size of B, record size of R, then we can define something called the blocking factor, BFR, and that means the B divided by R, and we take round down, that's the flow function. So that's actually tell me how many I can accommodate, right? Okay, let me give you an example, then we'll go to this. Okay, so I'm going to give you really easy to do calculation. And in real world, you don't have a number like this, okay? Just simply just make the calculation easy. So say I have a 70, that's the size of a block B here. And I have record size is 20. Okay, you don't have 70 as the number in reality, okay? But just, so, okay, so this one means I can put a record of 20 here, right? Okay, and I put another record 20 here, and I put another record of 20 here, and I'm going to have a space left here, right? So I can totally put 3 records, and that's the blocking factor BFR here. Okay, so what is BFR? That's B divided by R, and that's actually equals to 70. That's 3, right? So that's because you round up. Okay, so BFR actually tell you how many block in the block, how many records you can accommodate, and that's 3 here. So as a result, what is the unused space? B, that's the original total, and BFR, how many I have, and the size of each. That means how many bytes actually consumed already. So the total minus consumed is unused space. So in this case, B is 70 minus BFR, already calculated 3, times size of R is 20. So this is 10. So you can see this unused is 10. Okay. All right, and let's see the spanning record, and to use the unused space, like this case, there's an unused space here. And what can we do on that? So this first way, we can use unused space. We can separate a record into two parts. One part is use unused space, and the other part is using something else. So let me show this to you. Okay, so I have a block here, and I have one record, another record, another record, and then I have a little bit space left. So I'm going to put a part of my record. So each of the record, like this R1, R2, R3, right? So I'm going to have, say this is R4, but this is only part 1 can be here. This is not big enough to hold everything of record 4. So I'm going to have a pointer here, and that's this pointer point to another block. So in the other block, and for record 4, the other part, say part 2, will be in the other part. So you can see we reuse the space, right? So this is for part of 4, and this is also part of it. So this red color plus this red color is the whole thing of record 4. And that's pointer allow us to know where's a second part of record 4 here. So we can see the good thing about this is we do not waste space, right? So we can see we use the space, but the disadvantage is for one record, you have to cross the boundary of the block, right? So remember I talk about when you retrieve information, right? Even you only need a portion of things in the block, right? Only need one student in the block, but you still need the whole block. So this case, you do need more than one, just because this is separated into 2 if you want to load anything related to record 4. Okay, so when a record is larger than one block, so sometimes it happens, then this is the only way you can use. You have to use span the record, right? Okay, so let's see the other one, unspent. This is even easier. Simply, we do not want to use the unused space. Just leave this like this one, right? So make it empty. We don't want to use it. So they are not allowed to cross the boundary. We are in the with wasting some storage, right? But also we don't need to worry about loading 2 blocks in order to get one record. So this can be a good way if we use a fixed length record, right? Remember, this is the one we know every single one at which position is what. Because they make the record start in one location. So for the variable length one, when we have no fixed size one, then if they are not fixed size, they are variable length, and then either span or unspent can be used. Yeah, but just the fixed length one is the best to use combined with the unspanned way. Okay, so let's move on to the file header. So this is also called a file descriptor. It is at the beginning of each file, and you know, it needs to give some information about this file. Otherwise, we don't know the file has what, right? So, for example, the file block, what is the disk address, and any record information formatting, like the field length, order of field, for fixed length one, unspanned record, and also some special characters. You know, this is the one we didn't cover. So like variable length one, we have more things like separators, you know, all those things in order to understand the variable length one. But in general, you just need to know file header has information that allow us to know what is the file about, the structure of the file. Okay. All right, so the next thing we want to see is the operation on files. And they are very straightforward. So I'm going to just quickly go through them. So you can open the files, you can read, right? Read the item, you can find or locate certain things. You can find the next one. Okay, and you can do delete, modify, right? So they are pretty straightforward. The name itself tell you insert, close, reset, and found all, found the end, right? And found ordered and reorganize. This is the only thing I want to mention. So what is reorganize? Sometimes we need to reorganize the files. Periodically, we reorganize the files. For example, reorder specific field, and sometimes like the next topic we'll have, like when we have you know, sorted the file, all those things, and we delete things, we want to you know, reorganize things. So the file, we can utilize the things like, for example, we put a deletion marker, things like that. So we be able to make the file into certain format, then we can continue working on that. So reorganization itself will just tell you I'm to organize, right? Reorganize them. But how to reorganize, this is actually what kind of reorganization you're going to do. It depends on what kind of file we have, right? So in other words, it makes sense if we cover this one within different type of organization. That is actually the next one we're going to do. Okay. So before 24, so slides 1 to 23, they are more like you know, background about what's going on here. And now we dig into the technical part, that is how can we organize the file records such that we can operate that more easily. So when I say operate, mainly we concern about retrieving. So how to get result, how can we retrieve the record from the disk efficiently, right? We want to get it fast. And in order to do that, what kind of organization can we do? Okay, and so this one we can think about an ordered record. That's one way to organize that. And another one is we can do so the unordered, right? So this is the one ordered, sorted file. That's the next one. And it seems like, you know, either you sort something or don't sort something, right? Put both, you know, the only two way. Actually, we have another way, and that's actually using hashing. Okay, so we're going to dig into each of them one by one. Let me start with the ordered record first. So that's the easy one. This is also called the heap or pile files. So then every new record, they are inserted at the end of the file. it's pretty much like you have a bookshelf, right? And whenever you have a new book and you have empty space, you put a new book at the end, put a new book at the end. So if we think about the files, so we already have some item here. And so this is the very last one. When we have a new one, I simply put at the end, and another new one put at the end. Okay, so new record insert at the end of the files. So the record insertion is efficient, right? Obviously, you can see it's efficient. We just need to know where is the end. I'll put in the end. Okay, that's it. Okay, but when we do search for the record, we have issue here. So if we go back to what we learned in 130, so you all pass that course, right? So when we go back to that, you will see, since this is not ordered, then I have to do linear search. What is linear search? That means I start from the beginning. I will see, is this something, so for example, I have like, this is all integers, and I want to see if 5 is something here. Where is it, right? So I want to see, is this a 5? It's not, then we'll move on to the next one, and not, move on to the next one. So somewhere, maybe we found the 5, maybe we just keep moving until the end we found the 5. And maybe even nothing until we finish the last element, we don't see a 5, right? So this is basically talk about, we have to go through the file. So this is very expensive. So depends on you are lucky or not, right? Depends on which number you want to search and what is the original date looks like. Maybe the first one is the one you get. Maybe this is the one somewhere in the middle, maybe the last one, maybe even not there, right? So so this is actually when you say big O, that's the linear time, right? So we say big O, this is linear time, so that's why it's called linear search. On average, is actually need to search half of the file on average, so it's quite expensive. We'll see other things about unsorted file in the next class. We'll do more next class.